Okay, so there's one last thing I want to throw at you guys before I'll let you go for today, which is, how do these situations change? How do the games that we're looking at change when the same people interact with each other over and over? Now, the reason this is going to be important to think about, right, is one of the things we mentioned early on, is that in many circumstances, where it seems like people have an opportunity to be selfish and screw each other over and ruin society, right, push us into a bad equilibrium, people don't end up acting like that, right? They end up choosing not to take advantage of each other, choosing to do the socially optimal thing rather than the individually optimal thing, when it seems like their private incentives should push them in the other direction. And one possible explanation for why that is maybe people care about maintaining their good relationships with others because they know they're going to see those people again and again. And if that's true, that would make some really have some really important implications, right? It would suggest that we should be less trusting of strangers than we should be of people we're familiar with. It should imply that it should be harder to maintain social order or keep people from acting selfishly in bigger, more anonymous cities than it would be in small towns or in tight-knit neighborhoods. And it would suggest that people are likely to do business with the same group of people over and over again, right? Those relationships should be really important. So to think about this, right, to think about whether interacting with the same people over and over could potentially change our behavior, right, give us a reason not to be selfish. Let's think about another version of the prisoner's dilemma. Let's imagine that, in addition to all the other stuff I'm making you do, let's say that I assign you some group projects, right? I put you with a partner, I tell you you've got to work on a big project that's going to be a big part of your grade. And the way that the project works, you and your partner are each going to work independently, then you come together at the end of the semester, see what's been accomplished, and get graded on your collective efforts. So you and your partner each have a decision to make. Which is, are you going to focus and work hard on the group project, or are you going to blow off the group project so that you've got more time to study for the final, which is individual? You decide to work hard, or slack off. Right? Your partner has the same choices. Let's imagine, just for the sake of this question, that you and your partner are both just real assholes, real grade-grubbing jerks who don't care about anyone but yourselves. So your payoffs are just going to be your final grades in the class. Right? You're not going to care at all about whether you're doing the right thing by your partner. Let's imagine, as a result, that if you work hard, your partner works hard, right? You're going to get a pretty good grade on the group project. Neither of you are going to get awesome grades on the final. So let's imagine that you're going to end up with an 85 in the class. Your partner is going to end up with an 85 in the class. If your partner works hard and you slack off, though, that's really great. Right, because then you're going to get a good group project grade and a good final grade, so you'll get a 90. Your poor sap of a partner is going to get a 75. Right, same thing, it's going to be symmetric. So if you work hard while your partner slacks off, you're going to be the one stuck with the 75. Right, they're going to get a 90. And if both of you slack off, right, you're going to leave easy points on the table. You'll both do well in the final, but your group project will be a disaster, so you'll both end up with 80s. Okay, so clearly, right, there's going to be a Nash equilibrium to this game. It's not going to be pretty, right, and a dominated strategy. Right, if your partner worked hard, your best move would be to slack off. If your partner slacked off, your best move would be to slack off. Same exact thing for your partner, right? If you worked hard, they'd slack off. If you slack off, they'd slack off. Oy vey, right? Working hard is going to be strictly dominated, so the only thing that could possibly happen is that everyone slacks off. What a mess. But how would this change? Right? We're talking about sequential games, or repeated games. So how would this change if instead of working on a project with your partner once, you knew that you were going to work with this same person on a group project for every class for the rest of your time in college? Right? Let's say that you were going to have 10 group projects with the same person. And in each one, you were going to face exactly this same trade-off, exactly the same decision. Is it possible that the fact that you're going to have to work with this person again, right, 9 more times, would be a reason to behave well this time, right? Maybe you can tell them, look, we can either get 80s in every single class, or we can get together, work together, and get 85s in every single class, greatly improve our GPAs. The answer is sadly, no. That's not going to help you get to the better outcome. The reason for that is, maybe this time, right, your first of 10 projects, maybe it's going to make sense for you to work hard now to establish a reputation so that you can both get good grades in all of your classes. And maybe the second group project, that'll make sense too. But what about the 10th project, right? Second semester of senior year. You're looking at graduation. You know you're never going to need this person again. If you're, again, right, an amoral person, you're going to look and you're going to have exactly the same payoffs as if this was the first project you'd ever had together. Right, by the 10th project, you have no incentive to stay in your partner's good graces because you're never going to have an opportunity to screw them again. So in the 10th project, you're going to slack off, your partner's going to slack off. Just like it was a single game, because it is a single game. Okay. Well, if we know that you're going to both slack off in the 10th project, then there's really no point in working hard on the 9th project. Right? Because what's your partner going to do? Slack off? They're going to do that anyway. So if you're both going to slack off on the 10th project, we know you're also going to both slack off on the 9th project. And if you're both going to slack off on the 9th project, we know you're both going to slack off on the 8th project. And if you're both going to slack off on the 8th, 9th, and 10th projects, then the 7th project, right, you're both going to slack off. And so on and so forth and so forth. You're going to basically look at each other in the eyes, know that eventually this trust is going to break down, and therefore never cooperate with each other. Get mediocre grades your entire time in college, right? Get an 80 your entire time in college. So that's really sad, right? That's really disappointing. But that's not the only possible outcome when we have repeated games. So the reason that everything broke down here, right? The reason that we ended up never cooperating, never taking advantage of a mutually beneficial exchange, right? A mutually beneficial agreement, and instead getting B minuses in every class in college, is because we knew that on the 10th game, our cooperation would break down, and that gave us no reason to cooperate on the 9th game or the 8th game or the 7th game. So how would this problem change if we didn't know when we were playing our last game? In other words, what if instead of getting 10 interactions with each other, right, 10 group projects, we knew in each group project that there was some chance, let's say 50%, some chance that we would work together on another project, right? In that case, we could never say for sure that we were done with this person. Potentially, we would always benefit from staying in their good graces. Now, of course, the problem with this is, what we've just described is an unbelievably more complicated problem than the one we've talked about before, right? Because instead of talking about one decision, do I work hard or slack off? Now I'm kind of talking about infinity decisions, right? Do I work hard and slack off? And every possible game that I would end up playing with this person should be anywhere from one game to an infinite number of games with a very, very small chance, right? So how do we even begin to think about this? So the way that I would think about this, right, the first thing to notice is if I'm playing a game with you where I have a probability of P of getting another game, right, a 50% chance of playing with you again, that means I've got a 25% chance of playing with you a third time, right, a 1 in 8 chance of playing with you a fourth time, right, a 1 in 16 chance of playing with you a fifth time, and so on and so forth and so forth. Now, after this game, if we end up playing again, it'll be exactly the same situation, right? I'll have a 1 in 2 chance of playing with you again, a 1 in 4 chance of playing with you 2 more times, a 1 in 8 chance of playing with you 3 more times, etc., etc., etc. What that means is, whatever I decide to do now is gonna be what I decide to do next time, right? Because if we end up playing again, I'll have the exact same incentives as I had the time before. As a result, if I cheat you now, you can be confident that I'll cheat you forever. And if I cooperate with you now, you can be confident that I'll cooperate with you forever. This is an idea called the Grimm trigger. Which is essentially once cooperation breaks down, it breaks forever. So given that, I really have two choices. I can either work with you all the time, or I can screw you on the first project, and then end up getting 80s on every class for the end of time. Now, I want to warn you, what I'm about to do is going to get into some semi-funky math, so please don't worry too much about the details. I'm not going to ask you to replicate this, but I do want you to see it and think about it, because it's pretty cool. So let's imagine that I knew you'd cooperate with me the first time, right? But I knew that if I ended up slacking off the first time, then you would slack off on every project for the rest of eternity, right? Every other project that we could ever participate in. In that case, I have two choices, right? So choice one is to work hard every time. And in that case, right, my payoff would be I get an 85 on my first project, right? Because we both work hard, we both get 85s. I get an 85 on my second project, but I only get a second project with probability P, right? And if I ended up working on a third project, right, let's say that P is 50%, that would be a 1 in 25 chance. There's a chance of P squared that I get an 85 on that project too. And so on and so on and so forth, until we get to P to the infinity, right, times 85. I can call this, you may or may not have ever seen this before, the sum from t equals 0 to infinity of p to the t times 85. Now, on the other hand, I could slack off every time. If we imagine that your partner chose to work hard, right, so the only reason that slacking off would ever help you, then you'd get a 90 in your first class, right? That's pretty nice, because your partner's a sucker. But then, for all time, right, any future projects, you're going to get an 80. So it'll be p times 80 plus p squared times 80 plus dot dot dot, which we could call 90 plus the infinite sum from t equals 1 to infinity, p to the t times 85. Right? So, is it going to be worth it for me to work hard? It'll be worth it for me to work hard as long as this is bigger than this. In other words, we need that 85 plus the sum from t equals 1 to infinity of 85 times p to the t. Right, just to pull out the first one, has to be greater than or equal to 90 plus the infinite sum of 80 times p to the t. So just to rearrange things a little bit, this means that the infinite sum of 85 minus 80 times p to the t has to be greater than or equal to 90 minus 85. Right? Makes sense? Basically, each of these things, right, 85 times p minus 80 times p. 85 times p squared minus 80p squared, et cetera, et cetera, et cetera. So all we need to know now is what this thing is, right? 85 minus 80 to the p squared times p to the t, right? In other words, the infinite sum, t equals 1 to infinity of 5 times p to the t, greater than or equal to 5. Now this thing turns out not to be as difficult to deal with as we might expect. The reason for this is, we could write this, right, sum from t equals 1 to infinity of 5 times p to the t, right, is going to be equal to 5p plus 5p squared plus yada yada yada. What this means is, if I multiply both sides of this equation by 1 minus p, I'd say 1 minus p times the sum from t equals 1 to infinity of 5p to the t. This is just a mathematical digression, by the way, is going to equal 5p plus 5p squared plus yada 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 minus 5p squared plus yada 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 plus 5p to the infinity. Now 5p to the infinity is 0, so this just goes away, and I'm going to end up being able to say 1 minus p times the infinite sum 5p to the t is just going to equal 5 times p, which tells me that this infinite sum is going to equal 5p over 1 minus p. So again, take it or leave it. Don't worry too much about this. Just want to show you where this next step is coming from. So I can say 5p over 1 minus p greater than or equal to 5. Right? In other words, p has to be greater than or equal to 1 minus p. Right? P has to be greater than or equal to 1/2. So what did we just conclude? We concluded that so long as the likelihood that you'll interact with this person again and again and again and again is high enough, right? As long as you're more likely than not, in this particular case, to interact with this other person again, you can end up cooperating with someone because you expect to see them again, who you wouldn't have ever cooperated with in a single interaction. So whereas finitely repeated games, right, games that you know you'll repeat 10 times or 20 times or 30 times, won't lead you to cooperate. Games that are going to be repeated an unknown number of times, or potentially infinitely repeated games, will lead you to cooperate. Or might lead you to cooperate, I should say. So is this the explanation for why people can be kind to each other, or look out for each other, or do the socially beneficial thing, even when it doesn't seem like they have a direct self-interest in doing so? Is it just because we're imagining that we might interact with the same people in the future, and as a result we think about games as infinitely repeated? Probably not exactly, right? Probably hopefully, most of us would be willing to go out of our way to help someone, even if we didn't expect to interact with them in the future. And probably none of us are doing this sort of careful calculation of how valuable it will be to stay in someone's good graces. However, this sort of analysis might actually be pretty meaningful if we think about that basic propensity, right? Our likelihood to view strangers with suspicion or view strangers as potentially helpful, the value we place on maintaining a good reputation or on being kind to others, might in itself come out of implicitly who we see successful in our society, who we see unsuccessful in our society, which in turn reflects the underlying dynamics of cooperation. In other words, we might think that even if none of us are consciously doing this sort of analysis when we're making our decisions, if we grow up in an environment and we learn our lessons about the world in an environment where helping others and being cooperative pays off, because potentially, among other reasons, right, because we might interact with those same people again, or because our reputation might precede us, so that if we screw one person over, other people will treat us with suspicion, we might be more likely to be cooperative, social, and helpful than if we grow up in an environment where cheaters don't get punished. Okay, so that's all I want to throw at you today. Thank you so much for sticking with me through this. I can't wait to talk to you more about this in class. Thank you so much. Have a great night.